Hello everyone. Today we will review some of the basic concepts of geometry, starting with angles. Different types of angles formed either by the intersection of two straight lines or by bisecting another angle or even dissecting straight lines. And then we'll go on to talking about the angles about parallel lines. We will also discuss the naming convention given to angles based on their relationship with each other. So we'll start with talking on vertically opposite angles, which are formed by two intersecting straight lines. Now, vertically opposite angles are angles which are directly opposite to each other. And by the vertically opposite angles theorem, the angles will always be equal to each other. All right. So let's take an angle here in this figure, and I'll name that A. The angle directly opposite to it is this angle on the other side, which is a B. And by the theorem, these two angles will always be equal to each other. Likewise, there's another pair of angles vertically opposite in this figure, which is this angle here, C, is vertically opposite to the angle on the other side, which I'll call D. So C and D will also be equal to each other by the vertically opposite angle theorem. Now, the next kind of angles are called complementary angles, and they are angles that add up to a 90-degree angle. So in this figure, we have an angle over here. This angle here is bisected by another line into two angles. All right, so let me draw the angles here. So we have this angle, this complete angle here, which is a 90-degree angle. It's a right angle, and it's bisected, it's divided into two separate angles, and I'll name the two separate angles as angle A. The smaller angle as angle A, and the larger angle over here as angle B. And A and B, A plus B, adds up to 90 degrees, and therefore they are complementary angles. It said that A and B would be complementary angles if they add up to a right angle or a 90-degree angle. Now, supplementary angles are angles that add up to 180 degrees. So we can have two angles, A and B, and if they add up to 180 degrees, they are considered to be supplementary angles. Now recall that a straight line is a line which has a 180-degree angle about it. So here we have a straight line. The angle about the straight line is always 180 degrees. In other words, 180 degrees form a horizontal, or it can also form a vertical line, depending on where the angle starts from. All right. And in this figure over here, so this angle is 180 degree, but we see that the 180 degree angle is partitioned by a straight line connecting the horizontal line into two parts, correct? So we have angle A, all right, angle A on the left-hand side, and on the right-hand side, let's call that angle B. And the sum of these two angles is 180 degrees. Therefore, A and B are considered to be supplementary angles. We will now look at angles formed about parallel lines and transversals. So in this figure here, we have two parallel lines. These two purple lines are the parallel lines, and both of them are intersected by a straight line, which is called a transversal. So this red line is a transversal, which is any line which intersects two or more parallel lines is called a transversal. Now in this figure, we see that there are angles formed at the point of intersection between the parallel lines and the transversal. On the upper region, we have 4 angles A, B, C, D, and on the lower portion of the intersection, we have a set of 4 angles E, F, G, H, and we will see that they will have some special relationships between the angles. All right, so let's talk about vertically opposite angles first and see if we can identify any vertically opposite angles among the angles we have here. So let me first write here vertically opposite angles, right? Vertically opposite angles. So in the upper portion of the intersection, we see A and D, angle A and angle D are vertically opposite to each other. Likewise, angle B and angle C are vertically opposite to each other. And by the theorem on vertically opposite angles, these two angles, each of these two angles will be equal to each other. Therefore, A will be equal to angle A will be equal to angle D. Likewise, angle B will be equal to angle C. On the lower portion of the intersection, we will have E and H as vertically opposite angles and F and G as vertically opposite angle. Therefore, we can say that angle E is equal to angle H and angle F is equal to angle G. All right? Now we learn about a special set of angles formed by parallel lines and transversals called the alternate interior angles. So first I'm going to identify the interior angles in this figure, and then we will identify the special alternate interior angles, right? So interior angles are the angles that are within the two parallel lines, inside of the two parallel lines, therefore interior. And the alternate interior angles would be the angles which are diagonally opposite to each other. All right, so in this figure, C, D, E, F, these 4 angles are within the parallel lines. They are all the interior angles, but of them, the alternate interior angles would be the ones diagonally opposite to each other. So C and F are alternate interior angles. D and E are alternate interior angles. And there's a theorem on alternate interior angles that says that alternate interior angles are always equal to each other. Therefore, angle C and angle F, which are alternate interior, will be equal to each other always. So angle C will be equal to angle F. And let me just write it in its proper place. So angle C will be equal to angle F, being alternate interior, and angle D will be equal to angle E. All right. Now let's look at another set of angles called the alternate exterior angles. And as the name suggests, the exterior angles will be outside of the parallel lines. So in this figure, angles A, B, G and H are outside of the parallel lines, and they would be regarded as the exterior angles. All right, so I'm going to highlight these. A, B, G, H are the exterior angles. And what would be the alternate exterior angles? They are the angles that are across from each other, the exterior angles that are across from each other. So A and H are alternate exterior angles. Likewise, B and G are alternate exterior angles. And the theorem on alternate exterior angles says that they will always be equal to each other. Therefore, angle A will be equal to angle H, and angle B will be equal to angle G. So let's write that here. Angle A, the exterior angle, will be equal to the alternate exterior angle, which is angle H, and angle B will be equal to angle G. We'll now talk about another set of angles called the corresponding angles. All right. Now, corresponding angles are also equal to each other, but we first need to identify among these 8 angles which ones are corresponding angles. Now, to give you a better understanding, I have tried to put these 2 parallel lines side by side. It'll be easier for us to visualize the correspondence between the angles. All right. So the one on the left side will represent the angles, will represent the top parallel line, and the one to the right will represent the line at the bottom. All right. So I'm going to draw 2 transverses here on each of these lines, and the angles corresponding to the top one will be on the left. So I'm going to write here A, B, C, D, and the one to the right, I'm going to write the angles of the bottom line. So E, F, G, H. So over here, we see that angle A corresponds to angle E, correct? And angle B corresponds to angle F, C corresponds to G, and D corresponds to H. So let's highlight those. A corresponds to angle E. Then we have B corresponding to angle F. Then we have, let's pick another color here. C corresponds to angle G, and perhaps another color. D corresponds to H. All right. So now let's go back to our figure and look at the angles, the same angles that correspond. So A and E correspond, correct? So let's go back and pull our yellow and mark that. All right. A and E correspond. So A is an exterior angle and E is an interior angle. So A and E correspond with each other. Likewise, B, all right, B and F correspond with each other. Again, B being an exterior angle, F being an interior angle. Then we have C and G correspond with each other. So let's pull up the pink here. C and G correspond with each other, and D and H, all right, for the other one. So D and H, all right. And again, the corresponding angles will be equal. So let's write that. Angle A will be equal to angle E. Angle B will be equal to angle F. Angle C equals angle G, and the measure of angle D equals angle H, right? Now we'll talk about the relationship between what we call same side interior or exterior angles. Now the relationship between such angles is that they are supplementary angles. Supplementary angles add up to 180 degrees, right? So for these kind of angles, for these special angles, the relationship is not that they are equal, but they will sum up to 180 degree angle. That's what supplementary angles are, and that applies to same side interior exterior angles. So let's go back to our figure and look up which ones are same side interior and exterior angles. All right. So over here in this figure, The same side interior angles would be C and E, D and F. These are same side, they are same side interior angles. All right, so that means angle C plus angle E, angle C plus angle E will add up to 180 degrees. They are not equal, but they will sum up to 180 degrees. Which other angle will add up to 180 degrees? D and F, right? So angle D and angle F will add up to 180 degrees. They are same side interior angles. So angle D plus angle F will equal 180 degrees, correct? Then we have the exterior angles. Angle A and angle G will be equal to 180 degree when we add them up. Likewise, B and H will add up to 180 degrees. They are the same side exterior angles. All right, so let me just quickly highlight them so you see which ones. These are the exterior, same side exterior angles. And then, right, maybe the gray here, B and H. All right,